right, now I want to do problem 8. Again, we worked this out in class last time, but I just want to review the video here, just so you can kind of see it one more time if you need to. So we have a projectile launched with the horizontal, no, not with the horizontal, with an initial speed relative to the horizontal. So what that means is, think of the ground as sort of here, and then we launch this projectile at an angle, theta, and at a speed v naught. And then it goes up into the air, it reaches some top peak, and then lands on the ground. So we're launching at 35 meters per second and an angle of 50 degrees. So V naught x is going to be 35 times the cosine of 50, and Vy is going to be 35 times the sine of 50. So we're going to end up calculating that cosine and that sine right now. When I do that, I'm going to end up getting the following numbers. So 22.5 for V naught x, and that's meters per second because it's a component of velocity. And 26.8 meters per second in the y direction. Now that we've calculated those two components, we never touch either of these numbers again. So x naught is always 0, y naught is always 0. X is what we're trying to calculate, the horizontal range here. Now, V naught x, we just calculated that as 22.5. Y, so this is unknown. Y is the height that it goes. We don't know what that is. V naught in the y direction is going to be 26.8 meters per second. Now, here's what we're going to say. When we reach the top, the peak of our height, V in the y direction is going to end up being 0. Our acceleration is still 10, and our time is unknown. And I just want to be clear here. This Vy is the velocity at the very top of the trajectory. If we had any value for Vy, the thing would go still higher up. So at the very peak, Vy has to be 0 because it doesn't go any higher. So let's go ahead and get the maximum height reached. So to do that, in part A, I'm going to use the equation Vy squared is V naught y squared minus 2 G y minus y naught. I'm so sorry, I should write this as the acceleration. Okay, so that's going to be 0 squared equals 26.8 squared minus 2 times 10 times y minus 0. I'm going to actually fast forward and simplify here because I know that we worked this out in class last time. So 26.8 squared, and whoa, hang on, let me try that one more time. So 26.8 squared divided by 20 gives us 35.9 as our height. All right, now let's go ahead and solve the time it takes to go up. And if we do that, we can use Vy equals Vy equals negative AT plus V naught y. So 0 equals negative 10 times t plus 26.8. And when we actually get that number, we're going to get that the time to go up is 2.68. So the total time is going to be 2 times 2.68, and that's going to give us 5.36 seconds. So that's the answer to part B. And now we're ready to do part C, which is the horizontal range. And we're going to use the equation x equals v naught x times t total plus x sub 0, because I want the total range. This is only the time to go up. I double it to get the total time, because that's the time up and the time down. And I have to use that total time up and time down, to figure out what this total horizontal distance is. So with that in mind, this is 22.5 v naught x times t total, 5.36 plus 0. And so when we actually finish this problem out, we're going to end up getting 120.6 meters. All right, so that is question 8. And I'm just going to post PDF solutions to the second practice test.